because a log, or logarithm, is nothing more than the inverse of an exponential equation, just the opposite, just like the opposite of addition is subtraction, the opposite of logs is exponents, then we have some product properties, a quotient property, and a power property. Okay? So when we have like bases and we're multiplying like bases, what do we do to the powers? Add them. Okay? This is no different. We're multiplying like bases here, so we add the powers. And remember, the log base b of m is a power. The log base b of n is a power. So all we're doing is adding up those powers. Okay? So that's our first property of logarithms, is the product property. Multiplying like bases, add the powers. So what do you think the quotient property is going to tell us to do? Subtract. Absolutely. If we are dividing like bases, we're going to subtract the powers. And log base b of m is nothing more than a power. Log base b of n is nothing more than a power. So when we're dividing like bases, we subtract the powers. What did we do when we had powers to powers? Multiply. So the power property is going to say nothing more than, if you have a power to a power, multiply. Take that n out in front times the exponent. Okay? So everybody got those three written down? All right, next slide then. Let's work through that. If I have, remember, our calculators don't have all kinds of different log buttons, right? They have a log base 10 and a log base e, right? So if I told you that the log base 3 of 4, 3 to what power gets me 4, something a little bit more than 1, right? If I told you the log base 3 of 4 was about equal to 1.262, and I told you the log base 3 of 5 was about equal to 1.465, 4 to what power gets, or 3 to what power gets me 5? Not quite 1.5. Okay? If I gave you those two values, what can we do to find the log base 3 of 4/5? Subtract. So log base 3 of 4 was 1.262. Log base 3 of 5 was 1.465. What am I going to do to these numbers? Subtract them. And we break out our handy dandy calculator and we find our answer. Right? What'd you get? Very good. Okay. Next one. I'm going to put my sheet here. Bless you. Next one says that we have the log base 3 of what? $20. How are we going to get 20 using 5 and 4? Times. Okay. This is nothing different than the log base 3 of 5 times 4. Thank you. So what do we do when we are multiplying like bases? What did our product property say? Add. We're going to add those things. The log base 3 of 5 is about 1.465. We're adding on the log base 3 of 4, which is about 1.262. What are you going to get? 2.727. Good question. When we are only given 4 and 5, that's all we've got to work with. Okay? Exactly. They'll give you two numbers or two logs, and you've got to find a way to use those in some manner that's going to help you get the right answer. So this one was obvious. They were dividing. But this one wasn't so obvious. We had to take 4 times 5 to get our answer. Nope, that will be given to you. Okay, good question. Very good questions. Okay. All right, so what are we going to do next? Now we have a log base 3 of 25. How can I use 4 and or 5 to get 25? I like that idea. What about 1.465 plus 1.465? Why does she want to add those two together? Why is she using log base 3 of 5 twice? 25 is 5 squared, right? Okay. So you can look at it two ways. You can say this is the log base 3 of 5 squared, right? Or this is the log base 3 of 5 times 5. Okay. Sydney's way says take the 1.465 and add 1.465. But could you also just say this is 2 times the log base 3 of 5? Or 2 times 1.465? Bless you. Will we get the same result either way? Two ways of doing the same problem. Neither one's better, neither one's worse. Both are right. Okay? These questions make sense? What questions do you have on these? All right, next slide. Now we're going to ask you to use the properties of logarithms to expand things. This is nice and condensed, right? One nice little neat package. Okay? We want to see if we can make it bigger. Make it into a whole lot of things because it's going to help us solve these kinds of equations later on. Okay? So we have a ln. Remind me, what was ln all about? Log base e. Very good. Okay? Just a special log. Okay? ln of 3x to the 5th over y. What do you think we're going to do with that if we want to expand it or make it bigger? What does it say to do if we are multiplying like bases? Add them. Okay? So can we write this as the ln of 3 plus the ln of x to the 5th to start with? Would that take care of our numerator? Okay. What does it tell us to do if we are dividing? Subtract. So minus an ln of y. Just made it bigger, didn't we? Okay. Is there anything else that we can do to expand this? We used our product property. We used our quotient property. What else do we have? Power property. Okay. So what can we do with our power property here? Do we have a power? X to the fifth, right? So this can go to the front and call it the ln of 3 plus 5 times the ln of x minus the ln of y. And that's as expanded as it gets. Every coefficient and variable and power got used. Okay. Try the next one. All right, Kobe, what are we going to do here? We want to make it bigger. So we're multiplying like bases. That means make it bigger. So we're going to add, subtract, or do a power. Power here, right? When we're multiplying like bases, that means that we add, right? Okay. So log base 6 this time. And we have a 3. And we want to split it away from that x to the fourth. So we'll say plus log base 6 of x to the fourth. But are we done? Nope. Because we can do one more thing to it, right? What happens with that 4? Put it in front. It's going to go over here. So log base 6 of 3 plus 4 times the log base 6 of x. Questions you have on this slide? Just adding a bunch of logs to make it bigger using our properties. Okay? Next example. Now I've got it expanded, and I want you to condense it. So what's going to happen? What do you think, Ben? How are we going to condense this? I want to write it as one single log. And by the way, what's the base on this log? Remind me. Log base. There is no base. What does it mean? 10. Log base 10, the common log. Okay? So we want to make it all into one log. Okay? No more spreading it out. So this will be a log base 10 if you want to write the 10 to remind yourself. How do we condense that? What's it going to become? What do you think, Ben? Well, adding means what? What do you think, Alexis? Come on, guys. We're going to multiply, right? Okay. If it helps you to make this a power first and call this 3 to the fourth, then you can do that, right? Okay. And the plus means that we're multiplying. So we're going to take the 6 times this 3 to the fourth. But what does the minus sign mean? There's a division in there. So we're going to divide by, what are we dividing by? 3. We've just taken one big thing and made it into something small. Now, these are numbers that we can actually evaluate, right? So 3 to the fourth divided by 3 to the first is going to be 3 to the what? Come on. I want to give you time to work today. 3 to the fourth divided by 3 to the first, what do? Subtract power. So we're going to get 3 to the third. So we'll have a log base 10 of 6 times 3 cubed. And now it's just calculator work. 3 times 3 is 9, times 3 is 27. 27 times 6 is something that you want to use your calculator for, right? $162. Everybody get 162? Okay. And this one we could actually evaluate further. We're not going to ask you to, but we can take a log base 10 of 162 because we have that button on our calculator. Should be something bigger than 2, because log base 10 of 100 is 2. Okay. But not nearly as big as 3. Log base 10 of 1,000 is 3. Okay. All right, so we're going to use the properties of logs to condense this guy now. So just like before, take your exponent, bring it over here. That way you don't have to think about that anymore. Okay. Kaylee, you want to give it a try? Perfect. Good job. Okay. 4 is being, the ln of 4 is being added to the ln of 3 to the third. So we put a multiplication symbol between them. And it's being subtracting ln of 12. So we put a division bar there. Okay. Now let's simplify. 4 divided by 12, 4 over 12 reduces to 1/3. Okay, so we'll have a 3 in the denominator and a 3 cubed in the numerator. 3 cubed over 3 to the first is this is going to be when the 12 and the 4 reduce, we'll have a 3 cubed over 3, and 3 cubed over 3 is 3 to the second, which is 9. Okay, that's much less complicated than this, right? And we'll use these properties later when we're solving logarithms. Okay. What questions do you have on this slide? Okay, so you've got problems just like it to the right. We have one more thing to talk about, and you're going to love this next one. Okay, but you can't use it for nefarious purposes. You still have to know your properties of logarithms. Okay, your next slide is on the change of base formula. So I mentioned earlier that we only have 2 log buttons on our calculator. Log base 10, otherwise known as log, the common log, and log base e, the natural log. Okay, but we have something called the change of base formula that can let us find the log of anything, any base. Okay, can be very, very useful. So that means that you will have a calculator portion of your test and a non-calculator portion of your test to make sure you understand the properties of logarithms and aren't just using your calculator to work those problems. So the problems on your blue sheet you'll be responsible for without a calculator. Okay, so here's how it works. If a, b, and c are positive real numbers, b can't be 1 and c can't be 1, then the log base c of a will be, pick your favorite log base b of a over log base b of c. So you can either use your common log or your natural log. Okay. So what we're saying here is, don't think of it as the larger number as far as the size of the number or the magnitude of the value of the number is concerned, but the font of the number, okay? You take the log of the number next to the log, and then the log of the number that is the base, and we divide them, okay? So I'll wait for you to get that written down. And you get to choose your favorite log button. You can use the common log or the natural log, and you'll get the same result both times. Just can't intermix them. So the log base 10 of A over the log base 10 of C, or the natural log of A over the natural log of C. So based on our change of base formula, how will we evaluate the log base 7 of 11? What do you think, Laurel? Okay, so which log do you want to use? Log base 10 or natural log? Doesn't matter, does it? Okay, which one do you prefer? Which one's the easier button to find on your calculator? Okay, log base 10. So we're going to say the log base 10 of something over the log base 10 of something else. What goes in the top? The 11. What goes in the bottom? The 7. Okay, so plug in on your calculator log of 11 divided by log of 7. Let's see what you get. And we're going to go 4 decimal places here. Everybody get one about 1.2323? Now, Laurel used the common log. Someone try it with the natural log instead. If we take the natural log of 11 and divide it by the natural log of 7, do we also get 1.232? Make sure you plug it into your calculator so you know how these work. Everybody good? Yes? All right, we're convinced, right? Okay, so one last problem. How will we evaluate the log base 2 of 19? 2 to the 4th is 16. 2 to the 5th is 32. So it's going to be closer to 4 than 5. And that's all we could do before we knew the change of base formula, right? So we're going to plug it in. What are we going to plug in? You like common log or natural log? Log base 10, common log. Okay, so log base 10 over log base 10. Just can't change our bases, change our log base, which log we're using. Okay, what's in the top? Yep, what's in the bottom? Absolutely. So when you take the log of 19 over the log of 2, or the natural log of 19 over the natural log of 2, what do you get? Yep, 4.248 if you go to 3 decimal places, or 7.9 if you go to 4. Okay. Questions you have on these? None? All right. Assignment is to finish. You don't have a whole lot of problems here. They're very quick. So 16 problems. And you've got some time. Right there.